Hello, today we'll start chapter 3. So chapter 3 is very important. I believe it is maybe the most important chapter in this course. Why? Because it tells you how can you analyze a circuit, which means that you calculate the currents and voltage in every element in the circuit. And this is what we call circuit analysis, that you calculate current and voltage in the entire circuit. Of course, if you want to do that, you have to use the three basic laws, which is Ohm's law, Kirchhoff current law, and Kirchhoff voltage law. But if you want to do that, of course, it will be very hard for you. So this chapter tells you how to do it in an easy way or computerized way so that we can use a computer to solve it for us. That's why it's called the method of analysis. And we have two methods. One is called nodal analysis and the other one is mesh analysis. One of them is using Kirchhoff current law and the other one is using Kirchhoff voltage law. So it's up to you to use which one you like. So, for example, here, as I said, the motivation is that any circuit can be solved using Kirchhoff current law or Kirchhoff voltage law and Ohm's law. However, when the circuit gets bigger, it will be very hard for you to do it. So there is a need for a method that can be programmed so that we can use the computer to do it. The two ways are nodal analysis and mesh analysis. Let's start with nodal analysis. Nodal analysis, from the name, it depends on nodes. Okay, so the nodes, for example, if you look at this circuit has some nodes. So we are talking about, remember when we define nodes, node is the intersection between any two elements or more. But we are talking here about the node that has at least three nodes, three branches connected to it. Like for this one, for example, which I call it V1, and this one, which I call it V2. And of course, the ground here, this is one node, but they are all connected together because they are all connected. So this is another node, one node. Okay, so this is a first step, is that you need to define the nodes in your circuit. You need to define the nodes of your circuit. So these are the steps to solve the problem using nodal analysis. Number one, you select the nodes, and 1, 2, 3, as I said, and then you call them. This is V1, this is V2, and you select one as a reference. So this node here is a ground, so I select this one as a reference. So this is the 0 volts. And I call this one V1, I call this one V2. So what I need to do is to calculate these voltages, nodal voltages. I want to calculate V1, I want to calculate V2. And once I calculate V1 and V2, I can find any current and any voltage in the circuit. Okay, so as I said here, first we select one as a reference. I did that. Assign names, V1, V2, whatever, for the remaining nodes. And then we apply Kirchhoff current law at each node. So at this node, apply Kirchhoff current law. So I add a summation of currents, okay, entering the node equals summation of currents exiting the node. So this is a Kirchhoff current law. And you do the same here. Okay, so you add current here and current here and current here. And same for this one. Also, you do that. And to make it easy, we make assumption that let's calculate the currents exiting the nodes. Like for example, if you see this V1, so here's V1. So I want to calculate this I1 and I2 and I3. So in this case, I1, I plus I2 plus I3 equals 0. So to make it easy, for each node, you assume that the currents exiting the node, which is not right, of course, sometimes not right. Okay, so but you add the currents exiting the nodes. That's it. Okay, so it will make it I1 plus I2 plus I3 equals 0. Same for V2. So for V2 also, assume that you calculate this current plus this current plus this current, the total will be 0. Okay, so the question here is how can you calculate these currents? So you don't need to have currents. Actually, the objective is to find V1 and V2. not I1 and I2 and I3. So what you need to do is to find this I1, I2, and I3 in terms of what? In terms of the nodal voltages, V1 and V2. Okay, so in this case, you will create equation at V1 and another equation at V2, both in terms of what? V1 and V2. So in this case, you will have two equations and two unknowns. And once you do that, you can solve them to find V1 and V2. So let us see how can we find the current in terms of voltage. Of course, we have to use Ohm's law. This is how we do it. We know Ohm's law. This is Ohm's law. Voltage, current, resistance. Okay. To find the current, you have to use Ohm's law. This is the only option. Okay. Or otherwise, the current is supposed to be known. If the current is known, this means that you have a current source. If you have a current source, the current is known. If you don't have current source, you must use Ohm's law. You don't have any other option. Okay. So here, for example, if you look at these three examples, first three examples, this three here. Okay. In all these branches, we have current source. So now if I want to calculate I, this little I here, of course it is equal to the current source. That's it. So if you have a current source in the branch, the current equals the current source in magnitude, but not in positive or negative. Could be positive, could be negative, depending on the direction. For example, look at I. This current I is moving in this direction. Okay, while the current source is moving in the opposite direction. Okay, so I equal -2. I, in this case, equal -2. Because let's look at the second example. I is moving in this direction, and the current source is in the same direction. Then I equal +2. Very easy. If you have current source, this is how it works. Let's look at this one here. You have resistor. I don't care about resistor here. Why? Because you have current source. Because if I have current source that's 2 ampere, the current in this branch is 2 ampere. Doesn't matter what is the value of this resistor. So I is moving in this direction here. This is I. Okay. So I, the current, is moving in this direction, and the current source is in the other direction. Okay. So in this case, I equal what? Equal -2 ampere. Equal -2 ampere. So this is the first way to calculate the current. Well, actually, it is not calculate. It is actually is given. You know the current already. So the current here is -2, is +2, is -2, depending on the direction. So number one, you have a current source in the branch. Okay, only two ways. Number one, you have a current source in the branch. Second, you must have resistor. And in this case, you will use Ohm's law. Ohm's law. So if I have, for example, something like this, example like this one here, this one. So I want to calculate this I. How do I calculate I? I equal what? Equal V divided by R. This is Ohm's law. I equal V divided by R. I know this. Okay, but what is the value of V? This V is V1 minus V2. Okay, that's it. So in this case, if you want to calculate this I is moving from V1 to V2, okay, through R. So I equal V1 minus V2 divided by R. That's it. So if you have a resistor and you don't have any current source, so it is just subtract the voltage divided by the resistance. Okay, V1 minus V2 divided by R. And if you want to calculate the current from V2 to V1, the other direction, then in this case, what is the value of the current? So assume that you need to calculate this current here. This one. It will be what? It will be V2 minus V1 divided by R. That's it. V2 minus V1 divided by R. Will be very easy. If you have another situation like this one here, and you want to calculate R, it's the same. What's the difference? So if the other node is a reference, is 0, so okay, I need to calculate this current here. This current equal what? Equal V1 minus 0 volt divided by R, which is V1 divided by R. And if you have a source, if you have a voltage source, not current source, okay, it's the same. It's the same idea. Okay, I want to calculate this voltage here. I want to calculate this current here. So here is a current. It is like this. Okay. So I have this R, and I want to calculate the current in this direction. This I. Okay. So what is I? I equal, the voltage here is V1. So it is V1 minus the voltage at, I don't know, this point here. This is the second terminal of the resistor. Okay, so V1 minus this voltage, which I don't know. Okay, let us look at it later on. Divided by R. Okay, so V1 minus, I don't know. Okay, so now what we need to do is to find out what is the voltage at this point here. What's the voltage here? What is this voltage? Okay, so look at, when you look at this example here, this is a voltage source. You have a voltage source, positive, negative. This is a ground. Okay, and it's 5 volt. 5 volt. Okay, so if you have a 5 volt like this, the voltage here is 0 because this is a ground. Then the voltage here will be 5. That's it. So the voltage as this node is 5 volt. That's it. Okay, why it is positive 5, not negative 5? Because of course this is a positive side. It's a positive side. Okay, so this is a first another example. Okay, so here you see the voltage here is 0, then the voltage here is 5. Okay, so then what is the value of the current? Will be V1 minus this one here, which is 5, divided by R. So this will make it 5. V1 minus 5 divided by R. And if we have another situation like this one here, this one, okay, this one here. So again, it is the same. The idea is the same. I am looking at the resistor. I don't care, okay, about any other nodes. I just look at the two terminals of the resistor. This one is V1. This one, I don't know right now. Okay, divided by R. Okay, this one is 5 volt. Okay, let's see what this node is. So again, the current I equal what? Is I equal V1 minus, okay, I don't know what's the voltage here. If I know the voltage here, I will write it. Okay, divided by R. Okay, so what is the voltage here? The voltage here, depending on the source. This is 5 volt. What is the voltage at this node? It is V2. It is V2. It's given. It's V2. Okay. Then the voltage at the other node here will be V2 plus 5. Why it is plus? Because it is a positive side. It is a positive side. So this is higher. This one is higher by 5. Okay. So it will be V2 plus 5. Okay. Then in this case, you have to write this here. It is V2 plus 5, and please don't forget to add these brackets, because if you don't add the brackets, you may have a problem. Okay, you will have a problem, I'm sure. Okay, because if you said minus V2 plus 5, then this will be different. Okay, so if you have a resistor and voltage source, this is how we do it. Okay, just look at the two terminals of the resistor. You don't care about anything else. And look at the direction. The current is moving from V1 to this node, which I don't know. Okay, so find the voltage at this node. It has a relation with the voltage source. So like this one here, if this one is 0, this one is 0 plus 5, right? Which is 5. And this one is V2, this one is V2 plus 5. That's it. V2 plus 5. And then you add it here. Let's look at the next example. Here, for example. This one is a reference, and here is V1, and I want to calculate I. Remember this. No way to calculate the current in nodal analysis except by the two ways, which I explained to you before. Number one, you have a current source. Second, you have resistor. You don't have current source, you don't have resistor, you can't calculate the current right now, or you cannot write equation for the current right now. Nodal analysis. You can find it later on, but you don't write equation for the current. Only two options: current source, resistor. You don't have current source, you don't have resistor, think about something else. Don't write equation for the current. So I cannot say I, for example, I equal V1 minus 0 divided by, I don't know, 5, whatever. No. This is different. This is completely wrong. So you cannot say I equal V1 minus 0, okay, divided by 5. No, don't do that. Why? Because this 5 is not resistor. This is a voltage. So what they are doing here is that you divide voltage over voltage. What's voltage over voltage? Not current. Current equal voltage divided by resistance. So this must be resistance. So this is completely wrong. Okay? Then how we do this? This is very simple. This example is very simple. If this is 0, then this will be 0 plus 5. That's it. This one is 0. Then this one is 0 plus 5. That's it. And the same here. If this one is V2, then this one is what? Is V1 equal what? V1 for the second example here. V1 equal V2 plus 5. That's it. Okay? So you have to write another equation to find this one. But for the first one, for the first example, which is this one here, you don't need to even write equation at this node, at V1. Why? Because V1 is known now. If this one is 0, this one is 5. So V1 is 5. That's it. So this is the equation. You don't have to apply Kirchhoff current law at this node. But if you have another situation like this, where the voltage source is between two nodes and there is no resistor, then in this case you have to think about something else, which I will explain later on. But you know the relation now, that V1 equal what? V2 plus 5. Or you can say V1 minus V2 equal 5. Whatever, as you like. This is what we call it here supernode. This one is a supernode, and I will explain it later on.